The following video is the second part of the related rates series. In this problem, we have a 6-foot tall man walking away from a lamp post at night at a rate of 10 feet per second. The light casts a shadow on the ground, and we want to know how fast is the tip of his shadow moving when he's 8 feet from the base of the lamp post. Remember that step 1 in these problems is always to draw a picture representing the problem. So here I have a man and a 12-foot tall lamppost, which I think is, a 12-foot tall lamppost. And notice that the lamppost is casting light, and the light that's not able to hit the ground, that's hitting the man, that's where the shadow is caused. So notice that we end up with several triangles in this picture. The lamppost being 12 feet tall, the man being 6 feet tall. The shadow I'm labeling as S because notice that as the man walks away, it's possible that the length of the shadow is changing. Notice that the distance from the man to the pole I'm labeling as P because that's another distance that's changing. And I'm going to call X the length from the pole to the tip of the man's shadow. We know dp by dt is 10 feet per second because that's the rate that the man is walking away from the lamp pole. We want dx by dt when p equals 8 feet. We want how fast is the tip of his shadow changing, so the length from the pole to the tip of his shadow when p is 8 feet, so when the man is exactly 8 feet from the base of the lamppost. We need to relate x and p somehow. And the way to do that is to use similar triangles. Remember, with similar triangles, we'll take the base of the big triangle related to the base of the little triangle as the height of the big triangle is related to the height of the little triangle. So 12 is to x as 6 is to s. In other words, 12 over x equals 6 over s. We wanted to relate x and p, however, and so far we've related x and s. So notice that p is related to s because x minus p is s. So we get as our equation 12 over x equals 6 over x minus p. We can multiply both sides to get rid of the fractions, and we can end up with 12x minus p equals 6x. And now when we take the derivative of both sides with respect to t, we get 12 times dx by dt minus dp by dt equals 6 times dx by dt. We plug in the values that we know, so we knew the dp by dt was 10, and we're looking for dx by dt. So now we collect all the dx by dt's together and get everything else on the other side of the equation and solve for dx by dt. We get 20. The units on this will be the units of x over the units for t, so that will be feet per second. So the tip of the man's shadow is changing at a rate of 20 feet per second. Notice that the distance from the pole was irrelevant in this problem. It doesn't matter how far he is from the pole, the rate of change of the tip of his shadow is always going to be the same. For the following problem, we'll assume that gravel is falling off of a conveyor belt onto a cone-shaped pile at a rate of 10 cubic feet per minute. The radius of the pile is always twice the height, and we want to know how fast is the height changing when the radius of the pile is 200 feet. Step 1 is always to draw a picture, and anything that's changing over time gets its own variable. So notice that we have a cone, so I'd like to label the radius and the height of that cone. We know that the radius is always going to be twice the height, so r equals 2h. And we also know that the rate of change of the amount of gravel adding to this pile is 10 cubic feet per minute. So notice that that's a volume. The change in the volume of this cone is 10 cubic feet per minute. We want the change in the height when the radius is 200. So we want dH by dt when r equals 200 feet. For this problem, we'll need to know the volume of a cone is given by V equals 1/3 pi r squared times h. Since we know that r is equal to 2h, I can replace r by 2h in this problem and get 1/3 pi times 2h squared times h, which simplifies to 4h cubed. So we'll have 1/3 pi times 4h cubed. When I take the derivative of both sides with respect to t, I get dv by dt equals 4/3 times pi, so those are all the coefficients, all the constants, times 3h squared dH by dt. Plugging in the values that we know, we'll get 10 equals 4/3 pi times 3h squared dH by dt. Now we need to know h, and since r equals 2h, and we know r equals 200, we can solve for h. h will equal 100. So plugging back in for h, we can now solve for dH by dt, and we end up with dH by dt equals 10 over 4 pi times 10,000, which ends up being 1 over 4,000 pi. And the units on this will be the heights units, which are feet, over the time unit, which is minute. So we'll get feet per minute.